Welcome back to Algebra 2 class today. We are taking a break from radicals and we are on systems of equations. We backtracked. I skipped around in the book a lot, so we are on page 145, systems of equations, and we're talking about graphing them. There are multiple ways to deal with system of equations. We're going to learn them in the next few days. But the first one they teach you is by the graphing method. Pro tip for filming YouTube videos of the day is make sure your memory card is not full when you film a video, or else it won't film. Happened to me yesterday on this lesson, so again, take two. I'm sure by within the next 2 or 3 weeks I'll get all the kinks worked out, but for now, just more practice, I guess. So system of equation is where you have two equations that work together to find a solution that makes both of them true. That is a point for x and y that makes that statement true. Both of them true, not just one of them. There are, if you find one that makes it true, it's called consistent, and if you graph it, the lines will cross and make like an X, and that point where they cross is the answer. If the lines are parallel and they will never cross, it's called inconsistent, and you're not going to get an answer. And then if the line is, you draw one here and the next line is right on top of that, that's called dependent, which means it's the same line. Again, you're not going to get a cross, so you write dependent. So for this lesson, I'm going to do 3 examples. I have 2 of them on the board. I need a little bit of room here. And we're going to look at one. I just want to check to make sure we're recording. Eventually I'll get over the anxiety of messing up and not have to keep staring at the camera. But alright, so number 1 here, we have 2 equations, and basically we are going to make tables like we did in graphing for each equation to find points to plot. If I look at this first equation here, and I want to solve for one letter, I want to get a letter by itself. So if I go x plus y equals 4, I can move y to this side by the laws of algebra, and I get x equals 4 minus y. Okay, so when I'm solving this one, I will write it up here, x plus y equals 4. Whatever I put in for y will tell me what x is. So if I say y is 0, 4 minus 0 is 4, x has to be 4. If I say y is 3, 4 minus 3, if I put a 3 up here, 4 minus 3 is 1, so x would have to be 1. And if I say y is 4, 4 minus 4 makes 0, so x is 0, and I have points to plot that line. Okay, so I need to do it again with the other equation, and then I'm going to plot both of those lines on here. So with the second equation, x minus y equals 2, I will move y over. This time I add it because I do the opposite, and I get x equals 2 plus y. So now whatever I put in there for y, I have to add 2 to it. So if I say y is 1, 2 plus 1 makes 3. If I say y is 0, 2 plus 0 is 2. And if I say y is negative 1, put a negative 1 in there. 2 plus a negative 1, or 2 minus 1, is 1. So now I have 3 points for this line and 3 points for this line that I'm going to draw on here. And I'm going to do each graph in a different color so that it'll show up, because I'm doing them all in the same graph. I sent graph paper home with you in case you didn't have it. I would recommend for this assignment to make 3 or 4 graphs on the graph paper and do no more than 3 on each graph. So that it doesn't get too mixed up. You may use different colors if you'd like, which would help me, but if not, make sure you label your lines. So I'm looking at this one, And my first point is 4, 0. I go over to 4 and I don't move up any. My next point is 1, 3. I go over to 1, but I move up to 3. I put my dot there. And my last point is 0, 4. Means I don't move any. I stay at 0 and I go up to 4. And that is my first line. And that, if you label them, you put the equation for that line there. Okay, now I'm going to look at my second line, which is this one. And my first one is 3, 1. So I'll go up 3 and I go up 1. That's where my dot is. My next one is 2, 0. I'll go over 2, but I don't move any. And my next one is 1, negative 1, which is right here. So this line looks like this, and that is x minus y equals 2. And this is the point where they cross. That is going to be the answer to my system of equation, and it is 3, 1. So my answer, I would write on my paper, is 3, 1. But you notice I didn't get that without showing any work. Don't you just write 3, 1 down there and expect me to know how you got it. Okay, so make sure you're doing your work and showing your work. So let's look at 13. It's a little bit more complex of a problem. And we will work that one out, and then we'll do one more. So on 13, the equations are not as simple, and I will pull this one out over here. The first one is 4y minus x equals 4. Because x is negative, but there's no number here, I think it's easier to solve for that one. You can solve for y if you wish. Does not matter, but I'm going to move x over to that side, which gives me 4y equals 4 plus x, and then I'm going to subtract 4. So I'm going to be looking at x by itself, and then 4y minus 4 is my equation. Okay, so 4, and I'm going to put this one for this. So whatever I put in for y, I'm going to need to subtract 4 from it. Okay, so for instance, if I put a 1 in for y, 4 times 1 is 4, and 4 minus 4 is 0, so x is 0. Okay, if I put in a 2 for y, 4 times 2 is 8, and 8 minus 4 is 4. So I put a 2 in for y, then x has to be 4. Okay? What if I put a 0 in for y? Well, that cancels that out, and x equals negative 4, and I have my 3 for that line. Okay? So I'm going to go ahead and plot that one because I need this space to do the next equation, and I'll do this one in red. For this equation, my first one, x is 0, so I don't move right or left any, and I go up 1. That's my first dot. My next one is 4, 2, so I go up to 4, and I go up to 2. Don't worry that you're touching that line right there. Mine's in a different color, but if yours is not, just make them as neat as possible, and I'll be able to figure it out. My next one is negative 4, 0. So negative 4, 0 is right here, and this is a small sloped, I guess low sloped line. Like it's definitely need a ruler to keep up with it the best I can. Sometimes you may have to extend your lines if they don't cross but look like they will cross. And that one was that first equation, which was 4y minus x equals 4. And now I'm going to do the other one, this one right here, and work it out and see where they cross, if they cross. And if they don't cross, what will happen? So on this next one, I have 1/2 x equals 2y minus 2. Well, this is a fraction, so I'm not going to divide by that because we don't divide by fractions. What do? We flip them and multiply by the reciprocal. So I'm actually going to multiply by 2 over 1, which cancels that out on one side. 2 times 2y is 4y, and 2 times negative 2 is negative 4. Now, if you still have on your paper the last equation I did, that's what the last one looked like. So they're going to be the exact same thing no matter what I pick for these numbers. Even if I don't pick the same numbers, I'm still going to get that exact same line, which I'll show you. I'll pick some numbers that are a little different. We'll go ahead and put 3 in for y. 4 times 3 is 12, and 12 minus 4 is 8. We will go ahead and put let's keep one that we did. We'll go ahead and put 0 in for y, which will give us a negative 4, because 4 times 0 is 0, and 0 minus 4 is negative 4. And then let's put in, I don't want to go too big because my graph's not that big. So I'm trying to think. I guess we'll put a negative 1 in there. 4 times negative 1 is negative 4. Minus 4 would be a negative 8. So if this is negative 1, this is negative 8. So I picked 3 points, one of which is the same, just to show you that I knew, because this equation was the same, that it was the same line. And if you get that far and you know that, then you can know that this one's going to come out dependent or inconsistent. So I will plot those. 8, 3 goes 8 and 3, which is about right here. You have grid lines on yours, good. And then I have negative 4, 0, which is right here. And I have, well, this is kind of high. If I go around right here, we're looking at something like right here. And I have negative 8. Oh, yeah, let me do that. That's wrong. Negative 4, 0 is right here. And how about I do this to figure out where 3 is. 3, 8 is roughly about right here. Okay. And then negative, not 4, 0, negative 4, 0 is this mark right here. And then negative 8, 1, better use this just to make sure that I don't go too far, is right here. So if I connected those lines here the best I can, I'm not perfect, it's going to be on top of that other line that I just picked, which means it's the same line. So I'm going to write dependent for my answer. Okay, if that happens and it's the same line, or you end up with the same equation, it's going to be the same line. If it's exact, then you can just go ahead and write dependent after you got one of the lines graphed. No need to write the other one. All right, now we're going to do one more. I'm going to erase this area down here. Didn't do a very good job, so I'm going to try again. This is why I hate this board, it smears. It makes a nasty little film on there, but what are you going to do? Alright, so we're going to look at 15. Make my little swirly bracket, which, if you've taken my class at all, you know that if I don't think about it, I can make a good bracket, but if I'm consciously thinking on how to make it, it turns out horrible. So, we'll see what happens in the future. Alright, this is problem 15 in the book. I still got to make my X and Y brackets, boxes, tables, whatever you want to call them. And I'm going to pick the top equation, 3x equals 4y, and if I'm solving for x, I divide by 3, so x equals 4/3 y. When you're doing a table and you have a fraction, the easiest method would be to multiply 4 by a multiple of 3 so that it will divide out to a whole number. You can do fractions in here. You will just change them to a mixed number, but it's easier to do it that way. So, for instance, if I said y was 3, then that would be saying 4/3 times 3/1. The 3's cancel out and x would be 4. Okay? If I said y was -3, then I would have 4/3 times a -3, and that would just make this a -4 after those cancel out. And then if I said y was 6, I would have 4/3 times 6/1. 3 goes into 6 2 times, so 4 times 2 is 8. If that was 6, and there's my 3. So it's easier if you can manipulate your equation like that. If you can't, you can work with fractions. Just be careful on where you put your dots because they won't all line up. Alright, so I got blue and I got red, so I guess I'll go with some sort of purple for that line. Try to get it as straight as I can. And then my first one is 4 3, 4 3, which is somewhere right there. I made my dot kind of big because I want you to see it, but do not do that on yours. It'll adjust your line. Then I have -4, -3, so -4, -3, somewhere around here. And then I have 8 and 6. So 6 is right here, and 8 is right here, so somewhere right there. Again, be more precise with yours. And this ruler might not be long enough, so I'll have to use this. And that was 3x equals 4y. You see why I only want 3 of these on one? Because that's a mess as it is. And now I need to do my second one, so I'm going to erase this and work on this equation. Smear, smear, smear. So my second equation is 3x minus 4y equals 9, and I'll move my 4y over. Again, you don't always have to solve for x. To me, it's just easier in the equations that I've picked. So then I get 3x equals 4y plus 9. Then I have to divide everything by 3, and I get x equals 4/3 y plus 3, because 9 divided by 3 is 3, okay? So now whatever I pick for y, after I do that fractional thing, I need to add to it. Again, this is why you kind of want to pick multiples of 3 here, because if not, adding a whole number to a fraction, you got to do some conversion, so save yourself the time. So first of all, I'm going to pick 0, because that's an easy one. 0 times anything is 0, so that just leaves 3. Then I'm going to pick 3, so 4/3, wow, that's a sad 3 there. That equals 4, and I'm going to go ahead and pick, that equals 4, don't write that, and then that is 4 plus 3, that's 7. Then I'm going to go ahead and pick -3, which is going to give me a -4 when I do this, because I would just put that there. Those still cancel out, but that negative's there. So -4 plus 3, That's when I put a -3 in there. And I got a -4 plus 3 is a -1. Okay, so now I'm going to plot these. Hopefully I did it correctly. And see what kind of lines, see if these cross or what I have. So I have 3, 0, which is right here. I have 7, 3. Which is somewhere about right here. Actually, it's lower. That red line's in my way. And then I have -1, -3. So my next line looks like this. And you can see the two lines are parallel. I'll label my line. They're parallel. They're not going to cross. I mean, on my graph, they probably would eventually, but if they were truly parallel, they're not going to cross. If they're parallel, it's inconsistent, and you write inconsistent for your answer, okay? So you're either going to get an answer like that, you're going to get an answer that says dependent, or you're going to do inconsistent. Regardless, you still have to show that work, okay? I will also tell you that there are only 2 inconsistents and 4 dependents. So do not write that for every answer, or I'm not even going to grade it, okay? Thanks for watching. Have a good day. God bless.